In this video, we'll look at nomenclature, that is the naming system, specifically naming binary compounds, that is those that have two atoms, a metal and a nonmetal, which will form a compound. In this case, we'll talk about metals with a fixed charge, that is, they only have one. We don't have to decide which of the multiple charges that the metal has. We'll go with metals that only have one charge. Again, we'll use the periodic table that we can find on the Science Geek website, and we'll make use of knowledge gained in previous lessons to do with the relative charges that metals and nonmetals are likely to have when they form ions. This first example, let's go ahead and choose a couple of atoms from this periodic table. So we'll start off by selecting quite randomly. We'll say magnesium. What if magnesium was to bond with chlorine? Well, we know that magnesium is found here in the second column, so it is likely to have a charge that is 2 plus, and if we look on our periodic table, it says so right in the corner there, plus 2. And if we look at our chlorine, we know it will be negative 1 because it's in the halogens, and it's also written right there in the top. So magnesium has a charge that is 2 plus. Chlorine will form an ion that is negative 1. We use a strategy here to determine the chemical formula called the crossover technique. And all the crossover technique does is says, okay, let's go ahead and maintain our symbols for our chemicals, and we're going to cross the charge from the magnesium and bring it down here. And notice I'm writing it subscript. That means below the line. And the number that would have been here was a 1. It was implied, so we didn't actually write it. For the same reason, when we carry it down here, it's implied, so we don't write it. Which means the resulting formula is magnesium chloride. One way of looking at this is if I was to draw my magnesium as a cutout that had 2 points, one for each of the positives, and I was to look at my chlorines as each having an indent, a negative, that was 1. Those two things would structure together quite nicely to equal each other out. And that's ultimately what we're trying to depict here. Notice we've got one magnesium atom, and we required 2 of them to satisfy, or 2 of the chlorines to satisfy that one magnesium, because this thing had 2 electrons to lose, but each of these only had 1 electron space available to gain. How do we name? Well, that's an interesting thing too. So if I was to go back to I've got magnesium and my 2 chlorine ions. When I write the name of a binary compound, I write the name of the metal as it was. In this case, it was magnesium. And I take the name of the nonmetal, which in this case was chlorine, and I take the ene and I change that to an ide. So this becomes magnesium chloride. Let's do one more example. If I was to select sodium and I was to react it with oxygen. So I know that oxygen has a greater electronegativity, so the electrons from sodium would go to oxygen. We'd see a movement of electrons. Alright, well, what is sodium? Sodium's found on my periodic table with the element symbol as Na, and oxygen is an O. Well, if I look and find my sodium, I find it is in the first column, so it has a charge that's plus 1. I look over and find that my oxygen is 2 away from the noble gases or the inert gases, so it would have a charge of negative 2. Again, I use that crossover technique, resulting in Na2, my 2 from the oxygen, and my O would have a number 1, but I don't write the 1, it's implied. Again with the naming, so this would be sodium, because I write the name of the metal and then I modify my nonmetal to be, in this case, oxide. Pretty straightforward. Let's do it once in reverse. So if I was to take something with, let's use boron. If I had boron fluoride, well, I find that I know that boron is B, and I know that fluoride is a simple F. I know that the charge on my boron would be a positive 3, and I know that my fluorine would be a negative 1. Again, I do my crossover. I bring my 1 down on my boron, and I bring my 3 down to go with my fluorine, and I have BF3. So I can go from the name to the compound, or I can go from the compound to the name. In our next video, we'll look at what happens when a metal could have multiple charges.